uniform motion. What is uniform motion? What's uniform motion? So no acceleration. So the object moves with constant velocity, not constant speed, constant velocity. Uniform speed, you have to say uniform speed. If I just say uniformly, object is moving uniformly, it means uniform velocity. What is velocity? It has both speed and direction. Okay, so if this object is moving like that uniformly, means uniform velocity. That means over a period of time it's going to travel first of all like that, equal intervals in equal distances in equal intervals of time. In t seconds, it would have had a displacement of, in this case, 5t meters. So displacement is velocity into time. Now this is only true for uniform velocity or uniform motion. I have put an arrow to mark the fact that this is an arrow. Velocity could be like this, the displacement would be in that direction. Velocity is like this, the displacement would be in this direction. If I remove the arrow, then that means the displacement magnitude is velocity magnitude into time. Velocity magnitude is called speed. Okay. Now, this statement is only true for uniform motion. In general, if you look at displacement and you divide it by time, you won't get velocity. What you will get will be average velocity. Okay, so this is average velocity. I will mark it with a bar on top. Always bar will mean average. Arrow on that will mean vector. Okay, arrow will mean it's an arrow, which is a vector. Velocity is displacement by time. If I tell you that an object is moving at 5 meters per second for 4 seconds, what is its displacement? I can say that this is 20 meters. If I tell you an object has moved 20 meters in 4 seconds, what is its velocity? You can't find. How come? If I tell you that it is moving at 5 meters per second for 4 seconds, how come you find displacement, but you can't do displacement by time and find velocity? Because once I have told you 5 meters per second, it's constant. But once I told you 20 meters in 4 seconds, maybe it did 10 meters in the first 3 seconds, and in the last 1 second it completed the other 10 meters. It may not be constant. What we can find is something which is 5, but that 5 is not the velocity, that 5 is the average velocity. So these are ideas I am assuming you know. So velocity into time is displacement, but that's only true for uniform velocity. Average velocity into time is displacement is true always. Or displacement by time is average velocity. That is true always. That doesn't require it to be uniform velocity, uniform acceleration. Doesn't matter, it's always true. This is a definition. Okay. Now, if an object is accelerating, you know that the velocity will change. Okay. Now, let us assume that this fellow has a initial velocity u. Now, let us assume that this u was 3 meters per second. If it now has an acceleration, it's moving like this. It has an acceleration of 4 meters per second square. What does that mean? Every second the velocity increases by 4 meters per second. So 1 second later, what is its velocity? 3 plus 4, 7 meters per second. So 1 second later, it's here, 7 meters per second. 1 more second, so this is 1 second later. This is 0, t equals 0, this is t equals 1. What about 1 more second later? So 4 plus 7. So you have added extra 4. So 7 plus 4. Should I draw it here? Should I draw it there? Should I draw it here? I have taken this and yeah. So slightly this side. Why more?
Because it travels 7 meters in the next second.
Because its velocity has increased. It's now faster. We don't know whether it's travels 7 meters or not, but definitely it is going to be larger than this. The first gap is smaller, the second 1 second gap, it says 2 seconds, but that is 2 seconds time marker. The time interval is 1 second, the time interval here is 1 second. In the first 1 second it travels this much, the second 1 second it travels more because it's faster. Okay, and what is its velocity? 11 meters per second. By the third second it's traveled a lot more. Okay, and now what is its velocity? So I can write it as 3 plus 4 plus 4 plus 4 because acceleration was 4. So I can write 3 plus 4 into 3. Now this is u and that is t. So in t seconds what will it become? 3 plus 4 into t. Because in 4 seconds it will be 3 plus 4 into 4. 5 seconds 3 plus 4 into 5. Because every second it increases by 4. So in t seconds it will increase by 4t. What increases by 4t? 3 increases by 4t. So 3 plus 4t. What if instead of 3 it was 5? 5 plus 4t. If it was u plus 4t. Now this increase was not 4 but increase was u plus at. So now the velocity that you have after t seconds, we call it v, and that is u plus at. All that we are saying is, I started with u, 1 second later I got u plus a, 2 seconds later I got u plus a, so u plus 2a, u plus a plus a plus a, u plus 3a. Like that if I have 10 seconds later u plus 10a, t seconds later u plus ta or at. Okay. Now the key point to keep in mind here is change in the velocity. The change in the velocity was caused by the acceleration. The velocity was not caused by the acceleration. The change was caused because whatever I had in the beginning, it is added to that or subtracted from that, whichever way. Depends on whether you are moving this way or that way. But right now let's just say added. Now this depends on not just a, but how long are you waiting? Because every second a is going to add a. Acceleration is going to add a. So if I wait for 20 seconds, it will add 20a. If I wait for t seconds, it will add at. Okay, you already know this. And then the other formula that we are going to use a lot, okay, is this idea that for most situations, this is not, average velocity is not u plus v by 2 in most cases. But in one very important case, it is equal to u plus v by 2. And this case is uniform acceleration. For uniform acceleration, I am not proving it right now. We can discuss it, you can look at this in the course on straight line motion. But it's important to know that for uniform motion, the average velocity is initial velocity plus final velocity by 2. In general, it is not the case. Because it is uniformly increasing, it turns out to be just the beginning plus end by 2. Now, you probably already learnt a little bit of expressing motion in terms of graphs. So if I write velocities here, and I write time here. Now if for uniform accelerated motion at time 0, you start with u. As you progress, this point the velocity is v. The slope of this graph is called a. The area of this graph turns out to be the displacement. Okay. Now from this graph, it's very useful graph, but you already know that if you want to find the area, this is a trapezium. What is the area of a trapezium? Half of the parallel sides, sum of the parallel sides into height. Can I say half of the parallel sides is the average of the parallel sides? So that means average of this and this, average of this and this is u plus v by 2 into the height which is time t. So u plus v by 2 into t. Now this fellow is the average velocity. Okay. Displacement is average velocity into time always. But average velocity is u plus v by 2 for uniform acceleration. Okay. Now, don't worry too much about this right now. You'll have to use this a lot as we learn straight line motion. But right now I just want to use this in one place, that's all. Because you are going to move to a slightly more complex situation. But that complex situation luckily doesn't involve anything more than uniform motion and uniform acceleration of one kind. Okay, so let us just spend a little time on that alone. And by the way, since you know this much, it's easy to find out this is the area of the trapezium. But the area of the trapezium can also be found in another way. By doing this and doing that. What is this? U into T. UT. Okay, now what was that? That was V. What is this? U. So what is that? AT, V minus U, which is AT. So this is AT and this is T. That's a triangle. Half AT square. So this area is half AT square. So the whole area is UT plus half AT square. So you can say S is UT plus half AT square. I know this formula everybody knows. I would like you to think of S as average velocity into time, and average velocity as U plus V by 2 into time, therefore will give me S. You will find that this is actually quite useful, and many problems this will be easier to do than that.